Hello students, dear students, very good morning. As you know, chapter 10 was continuing. In chapter number 10, you have already attended lecture number 1, 2 and 3, where we discussed about spherical mirrors, various types of images formed by spherical mirror, and we also discussed reflection of light. In lecture number 4 today, our target is to study about refraction of light. I want to cover two topics today in our lecture number 4: refraction of light and refractive index. This word refraction of light is not new for us. You already have studied somewhere about refraction of light in previous standard. Reflection of light, one of the optical phenomenon we have already discussed. Now, refraction of light. Actually, before we study in detail about refraction of light, in textbook they have given, and in practically in daily life experience also, we have experienced so many optical phenomenon that is based on refraction of light. Take an example. If you have visited anytime or you have gone to swimming pool, and if the swimming pool is not filled with water, you try to observe its bottom. It is deeper. But after it is filled with water, you try to observe it. It looks shallow. It looks shallow means, understand, that is one of the phenomenon. It looks like the bottom of the swimming pool looks raised. That is one of the optical phenomenon. At home also, ઘરે પણ if a tank of water filled with water, overhead tank જોવા જાઓ તો the bottom feels raised. Even normally bucket, take bucket, try to observe its bottom and then fill it with water and then try to observe what happens. It looks like bucket is quite shallow and the bottom looks raised. One of the well-known example you must have searched anywhere and seen also, a glass half filled with water. Understand, you take one pencil and immerse that pencil in the water. What happens? The pencil looks broken. The part of the pencil inside the water and outside the water, the pencil looks broken at the interface of water and air. It looks broken when visualized, so that is also one type of refraction of light. So many examples we have seen practically. Understand, formation of rainbow, a beautiful colorful rainbow in the sky in monsoon season which you observe, that is also one of the example of refraction of light. So many examples we can quote to understand the practical experience of refraction of light in daily life. Even just try to understand, if a fish is inside the water in lake, you are not able to visualize its real position from outside the lake. That is also one type of refraction of light. Understand, suppose at home also you can experience it. Suppose on dining table, put one dish and put one coin. Stand at the side of the dining table. Try to visualize the coin. Then move yourself away. Try to visualize the coin. Move yourself away. Try to visualize the coin. At one instance, it happens that you are not able to visualize the coin. Ask somebody to pour some water. The moment somebody pours some water, you are able to visualize the coin again. So that is also one of the optical phenomenon, that is reflection of light. So many examples of refraction of light we have seen. Understand? All these optical phenomena which we experience in daily life are ultimately the refraction of light. Why it happens? Actually, when refraction of light can take place, refraction of light take place. Ultimately, you all know one of the basic phenomenon that light always travel in a straight path. Suppose if light is traveling in air medium, so it travel straight. Suppose light is traveling in glass, it travels straight because that's the basic feature of light. If light is traveling in water, it will travel straight. Understand, if light is traveling through kerosene, it will transfer or propagate straight. But if light means, I want to say that when light is traveling only in one transparent medium, it follows the basics, means it will travel in straight paths, that is a fact. But if light enters from one transparent medium to another transparent medium, what happens? Understand, ગોખેલું બોલવાનું નથી કે if light travel from one transparent medium to another, it bends. Not that way. Just at home also you just do one experiment. Make one dark line, suppose, on the paper. Understand? I'm the glass slab, but if you do not have glass slab, just you take any piece of glass and just place it or just keep over here. The moment you do this, what you see? Initially the light was traveling in air, now it enters in glass. So you will see this is medium air, this is medium glass. Initially light was traveling in air, so obviously it will travel straight. But moment it enters in other medium, what you will observe from here, it looks like the line is traveling this way. Means this was its original path and now it looks like traveling in this path, means it bends. Understand? And because it bends, so this gives us an idea that when light travels from, means when light enters from one transparent medium to another transparent medium, it slightly bends. Means you can say that when light enters from one transparent medium to another transparent medium, what happens? Its path of propagation means its path of moving, means its path of traveling changes, means the light ray bends a little. Understand that phenomenon is known as refraction of light. What we say it, refraction of light. Just want to make it more elaborate. You can understand this way. What I spoke, when light enters from one transparent medium to another, it changes its path of propagation, means it bends. Suppose I draw one line here. This line can be called line which I have drawn here. You can call it interface, separating two transparent mediums. Suppose this is medium number 1. Suppose we tell air. Suppose this is medium 2. We call it glass. Air and glass, two mediums. This line which I have drawn here, you can call this line as an interface separating two transparent medium. Understand? And when you compare two transparent medium, be always sure two transparent medium never have equal optical density. I will narrate this word later on in the same lecture. I am not speaking density. I am speaking the word optical density. Every transparent medium you know, that is vacuum, air, glass, water, kerosene, turpentine, diamond, ruby, whatever, every transparent medium has got different optical density. Here two medium, air and glass. Obviously air has less optical density than glass. You can say air as a rarer medium and glass as a denser medium. Suppose light ray is traveling in air and meeting this interface obliquely. So it travels from one transparent medium to another, means it will travel from air to glass. So actually if I trace, this is its original path in which it should go. But the moment it enters in glass, that is from rarer medium to denser medium, that is from air to glass, it can be from water to kerosene, whatever, then it bends, slightly bends, means its original path changes. Understand? Diagram this way. Understood? So this is, you can call incident ray. We can call it incident ray, and this ray can be called refracted ray. This is refracted ray. If I just draw one perpendicular line, as you know, in mirror also we were drawing perpendicular line. Suppose I just want to name AB as incident ray, suppose CD as refracted ray, suppose M dash is the normal. So obviously my dear student, you can understand AB is incident ray, CD is refracted ray, MM dash is the normal, આને કઈ નામ આપી દે. PQ is the interface separating two transparent medium, air and glass. So here is one angle formation take place. I can say it I. That is angle of incidence occurring between normal and incident ray at the point of incidence. Suppose it is O. So this is angle of incidence. Here you can also visualize one angle formation. We can call it angle of refraction. This angle is formed by normal and refracted ray at the point of incidence. So from this diagram, we are just trying to understand theoretically the phenomenon of refraction of light. Like reflection of light we studied in lecture 1 follows two specific rules equally. Refraction of light also follows two specific rules, which you can say law of refraction of light. No need to just learn only, understand from diagram and then try to memorize. And remember, my dear student, one more thing. Both the laws of refraction applies and true, correct, for any color of light. Understand, for any color of light or light of any color, these two laws which we are going to discuss just now applies, correct? Understand, for any light. Just try to understand. First law I am speaking, laws of refraction. I am not going to write, but you can note down with me. Laws of refraction. Actually, there are two laws of refraction, and both the laws are quite easy to understand and remember also. બહુ easy છે ને સમજવા પણ અને યાદ કરવા પણ. ફર્સ્ટ લો અહીંયા ધ્યાન આપવાનું. When I roll my pen, I will speak words, and at the same time I will dictate. So be very conscious and write. Laws of refraction number 1. I am speaking. Incident ray, normal and refracted ray. ફરીથી બોલું. Incident ray, normal and refracted ray to the interface separating two transparent media at the point of incidence all lie in the same plane. You must have noted down. I'll speak again. Incident ray, normal and refracted ray to the interface separating two transparent media at the point of incidence all lie in the same plane. First law. Second law. Second law, for remembering second law, you have to concentrate on angle of incidence and angle of refraction. I'll speak the law and write some necessary formula. Before I speak the law, I'm writing just one equation here. Try to understand it. This is law second. I'm first writing it just sine I. What is sine? That I'll just give you an idea. Sine R equal to constant. Actually, you all have idea about I and R. I, that means angle of incidence. R, that means angle of refraction. એનો તો idea છે જ. Actually, trigonometric functions you will study in maths. Understand, when trigonometry chapter start, you will study all various types of trigonometric ratios. So here you do not have to go in deep regarding trigonometric ratio. ખાલી આટલું યાદ રાખો, sine is one of the trigonometric ratio. What is the meaning of trigonometric ratio, how they are practically useful to us, that you will study in detail in maths. Just now, અત્યારે ખાલી એટલું યાદ રાખો કે sine is one of the trigonometric ratio. So let me describe the second law. I am speaking, you have to write word to word. The ratio of sine of angle of incidence. Just try to understand it from here. The ratio of sine of angle of incidence to the sine of angle of refraction always remains constant. I am speaking again the second law of refraction. The ratio of sine of angle of incidence to the sine of angle of refraction always remains constant. That is the second law. This second law of refraction is also known as Snell's law, that you should remember. If in exam you are asked, write Snell's law, so you have to write the second statement of laws of refraction, that the ratio of sine of angle of incidence to the sine of angle of refraction always remains constant. Okay? So we gave you some idea about laws of refraction in exam. It can be asked in 2 or 3 marks. At the end I will dictate the question also. They may ask question like define refraction of light and write the laws of refraction. So you have to first write definition and then these 2 law. It can happen that in exam in 1 mark they can ask you state Snell's law. So you just have to write the second law only. Again I am speaking, the ratio of sine of angle of incidence to the sine of angle of refraction always remains constant. Okay? So we got some idea about refraction of light. Now let us try to understand one experiment of glass slab. This is very important experiment because in this experiment again we are going to study phenomenon of refraction of light, and practically also we are going to study one very important word, and that word is called lateral shift. Now we are targeting refraction of light through, this is what we are targeting, through glass slab. This is the experiment we are going to study, and we are also going to study and lateral shift. This is what our target is now. What happens in refraction of light through glass slab, and also we are trying to study lateral shift. This is actually an experiment. In exam you can be asked, describe refraction of light through glass slab and also explain lateral shift. This word lateral shift is very important. Suppose you feel like you are already in physics laboratory and you are trying to perform this experiment. Karso શું? How will you perform the experiment? So suppose on table you spread a drawing sheet of paper, rectangular sheet of paper લઈ લો, and just you spread on the top of the table. Okay, take one rectangular glass slab. એવું માની લો કે આ બોર્ડ જે છે એ ટેબલ ટોપ છે અને આ વ્હાઇટ પાર્ટ દેખાય, that is rectangular white sheet of paper already. Suppose I have taken one glass slab. આટલું થોડું ઇરેઝ કરી નાખીએ એટલે વધારે પ્રોપર ડાયાગ્રામ બનાવી શકીએ. Later we have taken glass slab and we have placed, okay, suppose this is glass slab. Just try to understand. This is glass slab. After placing glass slab on the paper sheet, let me traces through pencil, outline draw करो and name it A, B, C, D. This is glass slab. I have placed, means we are visualizing from the top. Just try to understand. I'm just first drawing one line here. Okay. But actually કઈ રીતે, how to draw this line, that we'll understand. પણ અત્યારે ખાલી suppose a line is drawn. Actually, what you have to do, you have to take two pins. Suppose pin P1 and pin P2. You have to insert actually two pins on the paper sheet. Understand? After inserting two pins, this line you have to draw after removing the pen, and you have to draw a line passing through the holes made by pins on the paper sheet actually. After inserting two pins P1 and P2, understand, try to visualize the image of pin P1 and P2 through glass slab from this side. આમ glass slab હોય તો સાઈડમાંથી ઓબ્ઝર્વ કરો. Try to observe the image of pin P1 and P2 and try to insert two pins in such a way that images of P1, P2 and these two pins look in the same direction. Suppose one pin inserted P3 and another P4. Okay, again I am just drawing one line, right? I may call, suppose this ray as EF and this ray as GH, suppose. Okay, this line you have to draw after removing the pins and you have to trace it till it meet the AB interface and here it meet the CD interface. Understand? And now you just remove the glass slab and this point should be called O. As per textbook we are going, this is called O dash. Just join them. Okay. After joining them, let me draw one dotted line here which is perpendicular to this interface. It is perpendicular to this interface. I may call it MM dash. Another line I draw here. I may call it NN dash. That is also one normal. NN dash. Okay. So actually what happened? This was first medium, that is air. Second medium, that is glass. Again the ray emerged in air medium. So actually what happened? Initially the light ray was traveling in air, then it refracted. EF is the incident ray. This is incident ray. At interface AB, at point of incidence, so it got refracted and turned into refracted ray OO dash. And again at interface CD, again this is point of incidence, it will bend and move away from normal. GH can be called emergent ray. So the light ray got refracted twice at interface AB and at interface CD. First it goes from air to glass, then it goes from glass to air. Air is, as you know, rarer medium, glass denser medium, again air rarer medium. So what happens? Light ray initially went from air to glass and then glass to air, means rarer to denser, denser to rarer. What you can see actually here, okay, I just want to make you understand actually what has happened. Suppose there was no glass ray, the light ray must have traveled in its original direction. This is its original direction. Suppose I may call it somewhat LP. This was the original direction of light ray, but because it entered from air to glass, understand, it hasn't gone this way. Actually it has to go this way if there would be no glass slab, but because it goes from air to glass, it bends this way. Actually it has to go this way, but it bends towards normal. You understood? Means when light ray goes from air to glass, it bends towards normal. Again, my dear students, see, now it has to go in this way. This can be the original direction, but it bends away from the normal. Means when light ray goes from air to glass, means rarer to denser medium, it bends towards normal, and when it goes from glass to air, it bends away from the normal. So this can be understood this way. Light ray, air to glass bends towards normal, glass to air bends away from normal, rarer to denser towards normal, denser to rarer away from the normal. બાકી loss, all law are here angle of incidence. Here just try to visualize it more properly. This is angle of refraction. Again here angle of incidence, and here I can say angle of emergence, you can say E. Understand? Actually it is R2 angle of refraction, but it can be called angle of emergence. Okay, so laws of refraction are again followed. Incident ray, normal, refracted ray to the interface at the point of incidence all lie in the same plane. Understand? Okay, and at the same time angle of incidence, ભલે ડાયાગ્રામમાં થોડું ન દેખાય પણ એ સમજી લેવાનું. Angle of incidence and angle of refraction. Here also angle of incidence, angle of refraction, and that also follows the Snell's law. That means the ratio of sine of angle of incidence to the sine of angle of refraction always remains constant. Here one important word which I want to discuss with you. In exam this can be asked. Experiment thoroughly you have to explain, but this word is very important. Lateral shift. Actually what is lateral shift? Try to understand. This is original direction of incident ray. This is EOLP. જો બરાબર. This is original direction of incident ray. Understand? But it bends and then emerges out this way. So if I call this emergent ray, this is emergent ray. Try to understand. This is actually you can call incident ray because it is extended in the original direction only. This is incident ray, and this I may call emergent ray. I may call this emergent ray. Now what you observe here, this is incident ray extended, and this is emergent ray. Actually even refraction take place, ultimately the emergent ray and incident ray are parallel to each other. Understand? But incident ray, and when it becomes after refraction emergent ray, some shifting, sideward shifting take place between these two. So suppose I may call this OL. So this perpendicular distance between this, try to visualize very clearly. This perpendicular distance કોની વચ્ચે છે? Between incident ray and emergent ray. Means the incident ray shifts sideward by this perpendicular distance. So this perpendicular distance between incident ray and emergent ray is known as lateral shift. શું કહેવાય એને? Lateral shift. There is no mention in the textbook regarding lateral shift, but you have to understand in detail about lateral shift. Okay, so if somebody asks you what is lateral shift, how will you define? The perpendicular distance between incident ray and emergent ray is known as lateral shift. Actually these two angle I1 and R2, આ બેને કમ્પેર કરો તો both are equal. આ બંને equal જ હોય. And these two angle R1 અને I2 આ બંને પણ equal હોય. યાદ રાખવાનું, એક જ મીડિયમમાં બે એંગલ બને always equal જ હોય. These two angle R1 and I2 are happening in the medium glass, same medium. તો એ બે ઇક્વલ જ હોય. અન્ડરસ્ટેન્ડ? મીન્સ યુ કેન સે R1 equal to I2, એ હોય જ. અને એ જ રીતે I1 and R2 are happening in glass, તો યાદ જ રાખવાનું I1 equal to R2 હોય. This phenomenon you should remember. Okay? So clear one thing regarding lateral shift. Okay? What is lateral shift? Perpendicular distance between incident ray and emergent ray is known as lateral shift. Understood? Okay, so clear meaning of lateral shift. On which factor lateral shift depends? It may be asked. Lateral shift કોના ઉપર ડિપેન્ડ કરે? On which two factor? આ પણ નોટ ડાઉન કરી લેવાનું. On which two factor lateral shift depends? The first factor, type of the transparent material. It depends on type of the transparent, means material type. Second, it depends on distance between two parallel interface. અહીંયા બે પેરેલલ ઇન્ટરફેસ કયા? AB and CD. તો આ બંને વચ્ચેનું આ જે પરપેન્ડિક્યુલર ડિસ્ટન્સ જે છે ને, ડિસ્ટન્સ બિટવીન ટુ પેરેલલ ઇન્ટરફેસ, આ બંને એના ઉપર પણ lateral shift depends. So noted down two fact, textbookમાં નથી mentioned. First, lateral shift depends on type of the material. Second, perpendicular distance between two refracting surface or two refracting interface. Okay, so refraction topic got clear in your mind? Understood? Clear? So we have today discussed, actually I wanted to cover the topic of refractive index today, and in that topic of refractive index there are some numerical and objective also we need to discuss. Understand? But in this lecture we may not be able to cover it, because just covering the topic is not sufficient. We have to discuss refractive index in detail. We have to understand how refractive index relate with the Snell's law. Then we have to discuss some numericals, and then we have to discuss some objectives regarding refractive index. So today my target was there, but we may not be able to cover the topic of refractive index today. But then also, whatever we have discussed today, that looks sufficient. Okay? So my dear student, noted down each and everything. Any doubt, you can call me and contact me. Okay? But before we end today's lecture, this is homework for you. Homework for lecture number 4. First question. List out, note it down very carefully. List out any 6 phenomenon involving refraction of light. આપણે ઘણી ડિસ્કસ કરી, કોઈ પણ 6 લખો. List out any 6 phenomenon involving refraction of light. Second law. Define refraction and state the laws of refraction. Should I speak again? Define refraction and state the laws of refraction. Third, Question for today. Explain experiment of refraction of light through glass slab. Okay, and explain lateral shift. Should I speak the question again? Explain experiment of refraction of light through glass slab and explain lateral shift. Okay, noted down the third question. Now question number 4. Again I am speaking. It can be asked again in 2 mark. What is lateral shift? What is lateral shift? એમાં જ આગળ on which two factor lateral shift depends. What is lateral shift? On which two factor lateral shift depends. આગળનો ક્વેશ્ચન 3 આપ્યો, એમાં ડાયાગ્રામ સારી બનાવવાની ટ્રાય. Reporting is coming from associate. Most of the students are regularly submitting their homework in neat and clean writing. Still, some students are not writing properly. So